Alright. So like I said, today, yesterday we talked a lot about those graphs, like what each kind of graph was. Today we're going to look at graphs and we're going to answer questions based off those graphs. So first one, we have a box and whisker plot up here. Right? Test scores as a percentage for 6th period Spanish. What do all the different parts here, all these numbers, what does each number mean? Let's start with that, before we even look at the questions. What are those 5 numbers up there? People think they're slick. Mason.
Minimum.
Okay, which one's the minimum?
38.
38.
And then
Right, the one all the way to the small side. 38 is the minimum.
72 is like Q1, whatever it's called.
Q1 or the lower quartile, good.
88 is the median.
88 is the median.
96 is the upper quartile.
Upper quartile.
And 102 is the max.
Good. Right? Our 2 farthest points out, that's our minimum maximum. The 2 ends of the box, Q1, Q3, lower quartile, upper quartile, and that line in the middle is our median. Right? That 5 number summary we talked about. So if I look here, what was the high score of the test? What was it? 102. 102, right? The maximum, the max score was 102. Well, what percent of the class scored above 72? So what percent of the class is right here? 75%, Kuji. How do you know that, Mason says?
Because the 72 is the lower quartile and it's the 25 percentile.
Oh, yeah.
So, okay, I'm going to change the wording a little bit. Is that okay?
Yeah.
So, he knows that 72 is the lower quartile. Well, quartile means they split up into 4 equal parts, right? So each one of these parts between the minimum and Q1, that's 25% of my data. Between Q1 and the median, that's 25% of my data. Between the median and Q3, that's 25% of my data. Between Q3 and the maximum, that's 25% of my data. Even though they may look smaller, it's still 25% of the data. What happens is, it's not as spread out. It's only between 80 and 96. Each one of these pieces is 25% of my data. It's a quartile. So if I start at 72, I go through 1, 2, 3 quartiles. So 3 times 25 would give me 75%. Does that make sense? Right? Quartiles, 25% each. Okay? What was the median score of the test? Dom? 88, right? We said before, that line in the middle of our box and whisker plot is our median. Alright? Alright, Jalen. What percent of the class scored between 88 and 96?
25.
25, right? It's only 1 quartile, so it's 25% of our data. Do you think this test was too hard for the students? What do you guys think?
No.
Why do you guys say no? Liam, why did you say no?
Because most of them passed. Yeah, most of them got over 72.
So you're saying no, it wasn't too hard.
I don't know.
So you're saying,
Actually,
you're saying,
yeah,
it,
actually it's too hard.
you're saying it was too easy.
No, actually it's too hard because 25% failed.
Well, you don't know 25% failed. It could just, this could just be one person out here. The rest could be over here.
Oh yeah.
It was just perfect.
It was just perfect. I would say it was too easy. Right? I would say no. I would agree. It wasn't too hard. The reason I would cite is because either 50% of them got above an 88 or 75% of them got above a 72. So if anything, I would say it was too easy. I would say no, though. It's not too hard. No. Half of them got over an 88%. That's a pretty good percentage, right? So that's not too hard. Now, would you expect the mean to be above or below the median? So right here's our median. If we found the mean for our data, would you expect it to be above or below that? Bye, Paige. Have fun job shadowing.
Thank you.
Don't forget to do your homework.
I won't.
Okay. Above or below? Why do you say below, Tobias?
Actually, I might say above,
Why would you say above?
because most of the students got above the mean.
Well, but 50% of them are above the median. Kuji?
I'd say lower because there's like a lot of outliers on the lower, because you can see the 38 would drag down the mean, so it would be lower than the median.
I would agree with you. Right? I would say lower. You look here, our minimum is way farther from the median than the maximum. There's more outliers, or there's numbers that are farther away from the median that would influence our mean more than those upper numbers would. So I would say it's probably below. It's probably somewhere down here. I would agree. Does that make sense? Right? This is more spread out. I mean, there's more numbers to possibly drag it down. So I would say I'd expect it to be below the median. Guys, any questions on that problem? Right? I'm assuming there's going to be a portion on our test where we have to make graphs, like sugar graphs, bar graphs, box and whisker plots, stem and leaf plots, things like that. And I'm going to assume there's a portion of our test where we're just answering questions based off the graphs we're given. Are there any questions on those questions that we just did? No? Okay. The next one, what type of graph is this? You sure?
Yeah.
Why? How do you know it's a bar graph? They're not touching, there's spaces, right? So there's spaces in between them, it means it's a bar graph. Talking about scores on a die. How many times is the die thrown? How'd you eat that, Mason?
You add up all the frequencies.
Add up all the frequencies, right? 1 happened twice. 2 happened 6 times. 3 happened once. 4 happened 3 times. 5 times. 6 3 times. Add up their frequencies, right? Figure out how many times it happened. 2 plus 6 is 8, plus 1 is 9, 12, 17, 20. How many times was the die thrown? 20 times. What's the mean score thrown?
3.6. Supposed to round.
How do we do it? I like your answer, Mason, but I need to know how to do it. How do I find the mean from a table like this? Yeah.
You multiply the frequency by like the score and you add them all up.
Okay, so that's a good start, right? When we did a frequency table, we multiplied the score by the frequency. We added them all up. We can do the same thing off a bar graph. So I'm going to do that. I'm going to put the numbers below here. So 1 times 2 is 2. 2 times 6 is 12. 3 times 1 is 3. 4 times 3 is 12. 5 times 5 is 25. 6 times 3 is 18. And I'm going to add those all up, just like I did with the frequency table. Right? We can do the same thing on a bar graph. Take the frequency, multiply by the scores.
Did you put them into lists?
You could put them in a list. You could put your scores into one list. You can put your frequencies into another and do it that way. That would be perfectly fine too. So if I add all these up, I get 15, or 14, 17, 29, 54, 72. Okay, so I add them all up, but then what do I do to find my mean?
Divide by 20.
Divide by 20, divide by the frequency, right? We took our frequency table, we multiplied across, added them up, and then we divided by our frequency. So we're going to do the same thing here. Divide by 20. What do you get for a mean? 3.6. So our mean score thrown would be 3.6. 3.6. Right? Take the frequencies, multiply by the score, add those up, divide by the frequencies. Okay, if I'm betting on the number 5 to be the score to show up, what percent of the times did I win? So this is saying you bet on 5 to be the score every single time. What percent did you win? Well, how many times did 5 come up? 5. Out of, how many total times were there? 20. So, what percent of the time did we win then? 25% of the time. This isn't so bad right now, is it? Okay, the next one's one I really want to know about. Joe says the next row will be a 3. Fred says it'll be a 2. Who do you guys agree with and why? How many of you say Fred? How many of you say Joe? How many of you didn't vote? Jalen, why didn't you vote?
Because I didn't know the answer.
Anna, why didn't you vote?
Well, because there's an even chance of it being both of them.
But how do we know that?
Exactly.
Did it
When
say?
every time we roll a die,
Oh, yeah.
Did it
there's
say
a
it?
1/6 chance of it rolling, right? So you can agree with whoever you'd like, but the chances are the exact same for everybody. Just because it happened more often, like 2 happened 6 times and 3 happened once, doesn't mean it's more likely to happen the next time. It's still an even chance. It's still a 1/6 chance. Very good. So if that question was asked on the test and you put that you agreed with Joe and you explained why, you get it right. If you put Fred and you explain why, you get it right. There's no right or wrong answer to this, right? Now, you can agree with anyone. The chance is still 1/6. They have the same exact chance. Okay? Now, a question like that will not be asked on the test, where there's no wrong answer. But, yeah, if that question specifically is asked on the test, you just got to tell me why. Why do you think that? Yes, Mason.
Well, technically, it doesn't say it's a fair die.
It doesn't say it's a fair die. You're correct. But we are assuming it's a fair die. Unless stated otherwise, it's a fair die. Okay? Alright, do I need to write that out, or we got it? Dom? Got it? Gucci got it? Okay. Any questions? Alright, I'll keep going. Anna did a survey where she asked all the children in her school to name their favorite pet. The results are shown on the pie chart. Alright. If there were 800 children in the school, how many said their favorite pet was a fish? I got a fish. 32? How'd you get that?
800 times 0.04.
Where's .04 coming from?
4% said they liked fish.
4% said they liked fish. So if I take that 4%, .04, and I multiply by the total number of students who were asked, it should tell me how many said fish. Well, Liam, you said how many was that?
32.
32 children. Awesome. All right. What is the angle measure for the sector of the pie chart representing fish? So we know it's 4%, but what angle measure would that be?
14.
Where do you get that from?
Same thing, just with 360.
Why is it just a 360 now?
That's a circle.
The circle, right? There's 360 degrees in the circle. So if I take the percentage that's fish, 0.04, and I multiply by 360, because that's the whole circle, it should tell me what part of the circle is the fish, right? What do you get to the nearest tenth?
14.4.
14.4. 14.4 degrees. Guys, those first 2 questions, do they make sense? Yes? Okay. 3. If 720 children said their favorite pet was a dog, how many children said their favorite pet was a rabbit? This is a great question. This is not like the ones we just did. We have to think a little bit more for this one. It is 140. How'd you get that?
I did 720 over 0.36 equals x over 0.07.
So you set up as a proportion. Awesome. So you did 720 over 0.36 equals x over, what was the rabbit?
0.07.
0.07. That is awesome. That's exactly one way you could do it. You could set it up as a proportion. Right? I know there's 720 children, and that's 36%. X children for 7%, and you would cross multiply and solve, right? We would do 720 times 0.7, 0.07, excuse me, equals 0.36x, and divide by 0.36. That gets you 140 children. Now, that's not the only way you could do it. Did anyone think of another way to go about it? What if, well, how did we find part 1? You said there are 800 children and there's 4%. So we multiply those, right? Well, now it's the opposite. I want to know the total. So I'm going to take 0.36 times x equal to, how many said it? 720. Right? So instead of multiplying the percent by how many there are, I'm multiplying the percent by x to equal how many said dog. And it ends up being the same thing as Noel did. Right? We divide by 0.36. Divide by 0.36, we get x equals 2,000. Then we take that number and multiply by the 0.07. Gives us the same exact answer. It gets us 140 children. But 2 different ways to go about it. Either one works. Does that make sense? Yes? Okay. Well, then the last one, if 42 children said that a rabbit was their favorite, how many total children were surveyed? 600? How'd you get that? Over here or over here? The proportion? So you did 42 children said that rabbit was their favorite, and that was 7%. And we want to know the total over, what'd you put it over?
1.
Why'd you use 1? It's 100%, right? It's the total. It should be 100%. So if you want to do a proportion, you're more than welcome to again. Right? Cross multiply, we get 42 equals 0.07x. Or, if you look, you can set up just like this from the start, right? 0.07 times the total gives us 42 children. Either way gets us the same answer. Divide by 0.07. We get x equals how many children? 400? 600. That's what I said. I said 600. That's what I said. It squares. 600. 600 children. Does that make sense, guys? How we manipulate that data that we know to get what we want to know? Do we have any questions on that? Okay, I think we have 2 more graphs to go through. So I'm going to go through a line graph and a histogram. Should be pretty quick. Alright, line graph shows the record of time for 100-meter sprints from 64 to 2012. Wow, look at how nice that looks. From the graph, what is the maximum length of time for which the record remained unchanged? Did not change. What is the maximum length of time for which it went unchanged?
12 years.
Liam, how did you get 12 years?
When I saw it, like, at the beginning, it's like really flat.
It's really flat, right?
It's like the longest, and then it goes by 4s, so then you just count it.
Perfect. So it goes by 4s, you can just count. So that's 16. Or you could look at it and be like, well, it starts at 1968, ends at 1980. So 1980 minus 1968 gives me 12 years. Right? Find that flat part. If it's flat, it's not changing at all. So 1968 to 1980 is a 12-year period. Okay, then part B. Approximately what was the rate of change in the record time from 64 to 2012? Wow. This word right here. These words, I should say. Rate of change. What's that the same as? The slope. So what it's asking is, what is the slope from 1964 to 2012? Well, I need to find 1964, 2012. I need to find what they were on the y-axis at that point so I can find my slope. So if I look here, 1964, about 10.6, 10.06, excuse me. 10.06. 2012, right here we're at 9.58. So, is that still the record today? There, no? Oh, okay. Alright, so how do I find the slope or the rate of change then, once I found those 2 points?
2 minus y1
y2 minus y1 over x2 minus x1. So 9.58, step the page, 9.58, 58, minus 10.06 over 2012 minus 1964. We get negative 0.5 over 48. So let's say to the nearest hundredth. What does this come out to per year? Approximately what? 0.01. So negative 0.01 seconds per year. So on average, the record went down 0.01 seconds a year from 1964 to 2012. Does that make sense? Right? Look for those keywords, rate of change means slope, things like that. All right? See? We? No? We? All right. One last graph. Jim measured daily rainfall in millimeters at the same spot in his garden each day in the year. The results are displayed in the histogram below. On approximately how many days was the rainfall more than 10 millimeters? Well, first of all, let's look and see if we can figure out how many were on each day. Right? So 0 up to 5 is about 135 days. 5 up to 10 was about 80 days, we'll say. 10 up to 15 was 70 days. 15 up to 20, 45. 20 up to 25, 25. And then 25 up to 30 would have been 5. So if we're looking, I know that doesn't add up to 365, I think it adds up to 360, but they're estimates, right? As long as you're showing your work on the test, you'll be okay. Approximately how many days was the rainfall more than 10 millimeters? So if I'm looking at 10 here, more would be this way. How many days is that happened to be more than 10 millimeters? What do you say, Colton?
145.
145 days, right? Just add up those frequencies. 70 plus 45 plus 25 plus 5. Right? On approximately what percent of the days is the rainfall more than 15 millimeters? Well, how many days is it greater than 15? How many add these? 75. So 75 days, it was above 15 out of total what? I think I said it adds at 360, I think. All of them. It should have been 365, but we estimated. So ours add to 360 only, that's fine. Approximately what percent of the days was it above 15 millimeters? Liam, what'd you get?
21.
21%. Thank you. Last one for the day. Approximately what value would be the median? Wow. How could we figure that out? How could we find out the median? What?
Put it in a list, I guess.
You could put it in a list. Like if I'm just looking at the graph here. What do we normally do with our median? We normally list from least to greatest, then we cross off, right? Well, what if I just crossed off my bar graph here? Let's think about it. There's 135 days that were between 0 and 5, right? Well, 5, 30, 75, 145 So about 135 gets me to about here. So if I cross off this bar, and I cross off these bars, my median's got to fall between 5 and 10, right? Look at the frequencies, guys. If I could cross off 135 things between here and here, and then this one graph, my median's got to fall in the middle somewhere there, right? Right? Use your common sense a little bit. Think about it. Think about it abstractly. All right? So between 5 and 10. Approximate value of the median between 5 and 10. Does that make sense? Are there any questions on that? Anything? Anything at all? All right.